Welcome everyone. Today we are going to look at the proof of root 2 being irrational, and there are certain prerequisites that you need to know. They are as follows. Any integer multiplied by 2 is even, fairly obvious, and can be written in the form 2k because it would be a multiple of 2 where k is also an integer. Every even number is divisible by 2. Odd squared is odd and even squared is even. That's it. So let's move on to the proof. So we'll prove this by contradiction, hence assume on the contrary that root 2 is rational. This implies that root 2 can be written in the form p over q, where p and q are co-prime integers and q is not equal to 0. The q is not equal to 0 part is by the definition of rational number, and we have inserted the part of co-prime integers by ourselves. The definition of rational numbers does not state the co-prime integers part, but we need this for this proof. It's a key part. Now the key trick to solving this proof is that we need to prove that both the numerator and the denominator would be even and thus have a common factor of 2. You'll see why. Because this will be against our assumption that they are co-prime. So now we have root 2 is equals to p upon q. This implies, if I just get my pen out, this implies that when we square both sides, we get 2 is equals to p squared over q squared. And if we bring q squared to the other side, we get 2q squared is equals to p squared. This implies p squared is even. And hence p is even. In the brackets you could write even squared is even, just to give a reasoning for why it is what it is. Alright, so one step is done. We just need to prove that q is also even. So if p is even, so p can thus be written as 2k, where k is also an integer. So we have 2q squared. So 2q squared is equals to 2k whole squared. This implies 2q squared would be equal to 4k squared. And when we divide both sides by 2, we get q squared is equals to 2k squared. This implies q squared is even. And hence you can write q is even. But this implies they are not co-prime, as they would have 2 as a common factor, as they would have 2 as a common factor. And therefore this implies our assumption is incorrect. Is incorrect, and root 2 is rational, and this completes the proof. Rational. This completes the proof, so we'll just write QED for that. We have demonstrated what we wanted to demonstrate. Yeah, and that is also, this is what you just needed to know about. You just need to prove that both the numerator and the denominator would be even. That's the key to this proof, and that's it, you are done. Thank you very much for watching. If you enjoyed the video, please subscribe.